E.B. Lewis, the supplemental instructor for Dr. Byron Quinn's Natural Science Biology 1 course at Langston University, and I have composed a series of review videos that will help you with your final. This one focuses on Chapter 13, which talks about the structure of DNA. So we're going to be covering Watson and Crick, the structure of DNA and nucleotides. We're going to talk about base pairing, the semi-conservative model of DNA, and mutations. So first of all, one thing that you need to know is that Watson and Crick discovered the structure of DNA. Be familiar with those names. Watson and Crick, those were the two guys responsible for discovering the structure of DNA. And so you learned a long time ago that nucleic acids, which are a group of macromolecules, and that DNA and RNA fall into deoxyribonucleic acid. They're made up of nucleotides, and you learned that a long time ago. And that DNA takes the shape of a double helix. So the nucleotides, you know, are made up of a phosphate, a sugar, and a nitrogenous base. So the nitrogenous bases that are possible in DNA, for example, are adenine, thymine, cytosine, and guanine. And adenine pairs with thymine, cytosine pairs with guanine, which we'll discuss later on when we discuss base pairing. The principles of base pairing. So in DNA, like we just discussed, adenine always pairs with thymine, cytosine always pairs with guanine. In RNA, however, there is no thymine. So adenine will pair with uracil, and again, cytosine will pair with guanine. So if he gives you a question on your test that says, give the complementary DNA sequence, so he gives you this particular sequence, AATTCATGGCTTA. You know that adenine always pairs with thymine and cytosine always pairs with guanine. So since he gave you half, you can give the other half. And so your answer will look like this. Oops, excuse me. T, because A is paired with T's, and vice versa. C's paired with G's, A's pairs with T's, C's paired with G's. And so you're able to match it up like that. Well, what if he asked, give the complementary RNA sequence, and gave you that same beginning sequence? Well, you know that the only difference in RNA, between RNA and DNA, is that there is no thymine. There's uracil instead. So your complementary sequence, it wouldn't be AT, instead it would be AU. So AU, the T will pair with the A, the G's pair with the C's, A's pair with U's, not T's, T's pair with A's still, G's pair with C's, C's pair with G's, T's pair with A's, A's pair with U's. So it's pretty easy. So if he gives you half, you can give the other half just like that. You just have to understand the principles of base pairing. Also, just for some hints on your test, if he asked you to give the complementary DNA sequence, and in your answer choices, there were answer choices that had U's in them, you can eliminate that as your answer choice off top without even really reading any more into it, because you know the DNAs do not contain uracil. So if he asked to give you the complementary DNA sequence and there were answer choices that had U's in them, you could eliminate those. Now with RNA, same concept. If he asked you to give the complementary RNA sequence and there were answer choices with T's in them, you know that T's don't exist in RNA. We have U's instead. So you can eliminate all answer choices that had T's in them if they asked for the complementary RNA sequence. The other principle of DNA is just to know, and we've gone over this before, that DNA is semi-conservative. So half of it is old and half of it is new. We discussed this several times over again. So if he gives you the old half, you can make the other new half. So that's just a quick review. And the other concept that we just wanted to touch on real quick is that when you have incorrect base pairing, so you know that in the case of DNA, A's are supposed to pair with T's, G's are supposed to pair with C's. So if you have a case where you have a G pairing with the T, well, that's incorrect. That could lead to a point mutation. Now, most of the time, you have proofreaders, naturally occurring proofreaders in the body that will fix that and correct that to A and T. But this is a case of a point mutation right here. And that was quick. That covers Chapter 13 right